Hello, dear my student. After completion of purely resistive circuit with single phase AC supply, now we will discuss about purely inductive circuit with single phase AC supply. Let us consider a simple or we can say purely inductive circuit across a single phase AC supply as shown in below figure, where L is represent as purely inductance and VL is represent as voltage drop across inductor, and I is represent as instantaneous current flowing through the purely inductive circuit, and V is represent as a instantaneous voltage or supply voltage, or we can say applied voltage, where small v is equals to Vm sine omega t. Now applied voltage, now we know that applied voltage small v is equals to Vm sine omega t, where small v is represent as a instantaneous voltage and Vm is maximum voltage. This is considered as equation number V. Now our aim to find the relation between applied voltage and current flowing through the purely inductive circuit. According to definition of purely inductive circuit or inductance, we know that inductance does not accept the sudden change of current, and also the second also we can say inductance, it means inductance, the definition of inductance is the definition of inductance is the inductance is a property of material which opposes any change of current. Any change of current, it means V is equals to L into di by dt, or we can say I is equals to 1 upon L integration of V dt. Now substitute the value of instantaneous voltage V, then we get I is equals to 1 upon L integration of Vm sine omega t. Vm sine omega t. Now constant part is taking outside of the integration, then we get I is equals to Vm by L integration of sine omega t. The integration of sine omega t is equal to minus cos omega t upon omega. Now I is equals to Vm by omega L into minus cos omega t. This minus cos omega t is written as sine omega t minus 90. Sine omega t minus 90. Then I is equals to Vm upon omega L into sine omega t minus 90, where omega L is called as inductive reactance. It is represented by XL. So I is equals to Vm by XL into sine omega t minus 90. Here small I is represented as a instantaneous current, and this is considered as equation number 2. These instantaneous current become maximum when we are substituting sine omega t minus 90 is equals to 1. Then we get I max is equals to Vm by XL. It is considered equation number 3. Now from equation number 2 and equation number 3, I instantaneous is equals to I max into sine omega t minus 90. It is considered equation number 4. Now compare equation number 4 and equation number 1. We know that equation number 1 is V is equals to Vm sine omega t, and equation number 4, it means I is equals to Im sine omega t minus 90. This right side small letter of V is represented as instantaneous voltage, and in equation number 4 small I is represented as instantaneous current flowing through the purely inductive circuit. And in equation number 1, Vm is represented as maximum voltage, and equation number 4, Im is represented as maximum current, and sine omega t sine omega t, and in equation number 1 sine omega t, and equation number 4 has sine omega t minus 90. It means whenever we are comparing equation number 1 and equation number 4, means the applied voltage and applied current, it means we can say कि the current is having 90-degree lagging nature of applied voltage, 90-degree lagging nature of applied voltage, or in other terms we can say the voltage is 90-degree leading by flowing of the current through the purely inductive circuit. Now draw the phasor diagram. Phasor diagram, we know that in purely inductive circuit, voltage and current not having in same phase, it means the instantaneous voltage and instantaneous current having some phase difference. That phase difference is minus 90-degree. Minus sign is represented lagging nature. So the phasor diagram is represent applied voltage. If you are considering voltage as a reference, then with respect to voltage, current has 90-degree lagging nature. If you are considering current as a reference axis, then voltage is leading 90-degree by current. Now we want to draw the waveform diagram. In waveform diagram, you can see in the waveform diagram applied voltage and current. And first waveform diagram show V is equals to Vm sin omega t represent as a reference voltage, and I has 90-degree lagging nature of current. In waveform diagram 2, the I is equals to Im sin omega t is represent as a reference current, and V is equals to Vm sin omega t plus 90 is leading nature. So in waveform number 1, lagging nature of current. In waveform number 2, having voltage is leading nature. Both waveform diagram is right, but most preferable diagram is first waveform diagram. Now we want to find instantaneous power. We know that already about the instantaneous power. And power, it means the product of voltage and current. Suppose if you want to find the instantaneous power, it means the product of instantaneous voltage and instantaneous current. Now P is equals to instantaneous voltage into instantaneous current. Now substitute the value of instantaneous voltage and instantaneous current from equation number 1 and equation number 4. Then we get P is equals to Vm sin omega t Im sin omega t minus 90. Now Vm into Im sin omega t and sin omega t minus 90 can be written as minus cos omega t. Now we are taking minus sign in outside, so minus Vm into Im sin omega t cos omega t. Now 2 by 2 in this equation, now multiply 2 by 2, then Vm into Im by 2 and 2 into sin omega t into cos omega t. We can say 2 sin omega t cos omega t is equals to sin 2 omega t. Then P is equals to, and similarly Vm by root 2 and Im by root 2 is considered as Vrms into Irms. Then finally we get instantaneous power of purely inductive circuit. P is equals to minus Vrms into Irms into cos 2 omega t. This rectangular block is represented as a instantaneous power of purely inductive circuit. Now we want to find the average power of purely inductive circuit. Average power of purely inductive circuit. So now this instantaneous power integrate from 0 to 2 pi. Whenever we are integrating from 0 to 2 pi cos 2 omega t, then we get 0. It means in a purely inductive circuit consumes 0 power. So P average is equals to 0. This is the most important question according to Pune University. Now we will see the waveform diagram of instantaneous power. First we can draw the applied voltage. and second waveform we can draw the current flowing through the inductance. Now in first quarter half cycle you can see applied voltage is positive and current having a negative sign. The positive and negative multiply, the plus sign into minus sign become minus, it means power is negative. In second quarter half cycle current is positive, voltage is positive, the product of positive voltage and positive current become positive power. In for second quarter half cycle we are getting positive power. If you are seeing the power waveform diagram of purely inductive circuit, the first quarter half cycle cross sectional area and second quarter cycle cross sectional area are equal and opposite. So from this waveform diagram we can also conclude that the average power becomes zero in purely inductive circuit. After finding the purely instantaneous power of purely inductive circuit, now we will discuss about power factor. The definition of power factor does not change here. Same, the cosine angle of voltage and current is called as a power factor, and we can say the cosine or cos angle of applied voltage and applied current. Here the angle between voltage and current is 90 degree. It means power factor is cos 90. We know that cos 90 is equals to 0. It means 0 lagging power factor will be available in purely inductive circuit. After finding power factor, now we will discuss about phase angle. Phase angle, the definition of phase angle is does not change. The angle between applied voltage or current flowing through the any circuit, or we can say purely inductive circuit. The phase angle between applied voltage and purely inductive circuit is 90 degree. From the equation number 1 and equation number 2, or we can say from the phasor diagram, we know that the angle between applied voltage and current flowing through the purely inductive circuit is 90 degree. It means phase angle phi is equals to 90 degree. Phase is 90 degree.